Oh, are we zooming?
Okay.
Did you zoom yourself?
Yeah, I just record it.
You have no memory.
Thanks, Bobo.
Bobo keeps making calculus jokes.
Okay, we are looking at geometric power series today. So think back to geometric series because a lot of it's going to be with that. Okay. So we're specifically looking at series that look like 1 over 1 minus x, which resembles the sum of the geometric series, which was a over 1 minus r. Okay. So we're going to start writing this guy as a geometric series, and we can break down different parts of it as we need to make it into the geometric series we want. Okay. So we're going to use a lot of our stuff from geometric series to go through the rest of this. If I'm looking at 1 over 1 minus 2x, what's my a value? 1. What is my r value? 2x. Okay. And remember, I can write it as a geometric series that looks like this, a times r to the n. So if I'm writing my series, what would that look like? 2x to the n, good.
Does that C mean anything?
Means it's centered at 0. So if it wasn't centered at 0, we would have to do some work to kind of go around that. So on this next one, we'll look at not centered at 0. But centered at 0 makes it really easy for us.
Oh,
Okay.
that's not multiply. That's not multiply. Oh, that's C equals 0.
C equals
It's
0.
like a
Yeah,
difference.
sorry.
Okay.
Comma.
Is that all we have to do?
Well, we got to tell where it converges.
Never.
Okay. That's not true. Geometric series, remember we take the absolute value of r. And this also kind of looks like last time we compare it to 1.
And how do we know it's always less than 1? Does x have to be 1 or higher?
In the geometric series, we compare it to the absolute value of it to 1. And if it's less than 1, it converges.
Well, like what if it was 1/4? X was 1/4. Oh, never mind.
So
Never mind. I'm a
So we're trying to figure out where it converges.
oh, so then you do your -1.
So we've got to solve for x. So we're going to put 2x between 1 and -1, just like last time. Okay. Usually with a geometric series, remember your r is not, it doesn't usually have a variable attached to it in a regular geometric series. So in a regular geometric series, you'd be like 3/5 less than 1. It converges. I'm done. With geometric power series, the power comes from having some version of x down here, or some variable. And so now I'm having to solve for that x. What is x between?
-1/2 and 1/2.
Good. Okay. So we will say that our interval, no, that's a good question. So
We don't have to find it in brackets.
you do not.
So does it mean that it diverges on anything not within that interval, or is it just inconclusive?
It would diverge for anything not in that interval. So remember with geometric, if r is greater than 1, it would diverge. So because we're setting it strictly less than 1, within that interval, it will always converge. Anything equal or greater than 1 will automatically diverge. Okay, so actually that answers both parts. This here, we do not have to test our endpoints, which is always a good thing after last time. And then yes, anything outside of that interval would diverge because of the divergent condition.
Including the intervals, right?
Hmm?
Never mind. I understand.
Including the endpoints, yes. Okay. So if they ask me to write this as a geometric power series, there is my geometric power series. If they want to know where it converges on this interval. Okay.
Do you ever have it where it doesn't converge at all? Is that like a possibility?
It is a possibility, however unlikely. Okay.
Yes.
Questions on this first one?
I feel like we're gonna have to manipulate this next one, and I feel scared.
We are going to have to manipulate this next one because it is centered at 2. Okay. So I'm going to first take into account it being centered at 2. So instead of just x, I'm going to have x minus 2 because I have to account for that center. Now, this is no longer equivalent to f of x because I subtracted 2 in the denominator. To make it equivalent to f of x, what would I have to have done? Add 2. Okay. So we could simplify this and have 1 over 6 plus x minus 2. And now we have a power series that talks about what the center is. Okay. The problem being, we want it to look like this, a over 1 minus r. Do we have a 1 minus here? No. I have a 6. Okay. How do I get rid of a 6?
Multiply the top by 1. Negative 6.
No.
Wow.
Wait, no. Oh, would you separate the two first?
No.
Would you?
You're on the right track. We are going to multiply
By 1/6?
by 1/6, the reciprocal.
Oh, yeah.
So top and bottom by 1/6. So I'm going to have 1/6 up top. And then if I multiply the entire bottom by 1/6, this would become a 1. You're on the right track. How could I rewrite a positive
As 2 negatives.
as 2 negatives? Okay,
Can I ask a stupid question?
absolutely.
Why wouldn't you just rewrite 6 plus x minus 2 as 1 over 6 minus a negative x?
I can't have this be a 6. It needs to be a 1.
Oh, it has to, okay.
It has to be a 1. Okay. So I've got to change that to 1 and then make it 1 minus.
Oh, okay.
Okay. So now I can figure out what my A and my R are. What is A? 1/6. Okay, it's whatever is on top. What is R?
Negative 1/6x plus 1/3.
Okay,
Oh, do you not have to?
we don't have to distribute. It's okay. I will put that into my geometrics power series. So we have A times R to the n. So A is 1/6. R is negative 1/6, x minus 2 to the n. So that is our geometric power series.
So then, do you just put R in between your,
That is absolutely it. We take R in the absolute value and compare it to 1, which really means outside of the absolute value, it is with 1 and -1. Good.
most like, put all by 6
Yeah.
or -6?
Well, the absolute value will take care of the negative, right?
Oh, yes, you're right.
Okay. So yes, just multiply by 6. Okay, and then what? Add 2. So our interval is where?
-4 to 8.
Good.
Why did it change from, why 1/6 change from negative to positive?
The absolute value.
No, for sure.
Oh, on the test, yeah. Right now.
I thought so.
Okay. It is easier than 9.8.
I agree. I concur with that, actually.
Mostly because we don't have to test them.
Yeah.
That is my least favorite part.
I was probably proud.
Probably sucks to grade too, right?
Yeah, I'm thinking if it's
So we probably, yeah, probably just keep it up there.
Again?
Historically, would you call this test the lowest scores of the year? What's
How
the
is that
lowest
possible?
score?
I would call chapter 4 the lowest.
Have we taken chapter 4?
What's that one?
Calculus house.
I guess
Oh,
some people do better
yeah,
on
that
this
was
test.
See,
I know the calculus.
Oh, that's when we first learned, like, you stuff, right? I think.
I think USUB is 5,
There used to be like a Mr. Walden.
but I may be wrong.
I haven't done it. Maybe I.
Ultraviolet imaging.
Ultraviolet voodoo, I purposely do not test on because I would die. You would die, but I would die. Yeah, calculus home, for whatever reason, people hate calculus home.
Honestly, when you first teach it.
Maybe it's because you always call it calculus house.
I feel like
It is probably because I've always called it calculus house. You're right.
insert.
Yeah, it didn't feel that inviting. When we changed it to calculus home.
That was the difference. Okay.
I was like, I think it was just like, it's hard to grasp at first. Like, I remember when we first learned it, I was like, what? But now I like it.
It's more inviting. When we
Is
changed
it possible to pause the recording
Yes,
for the sake of the times we're right now, we're having of what's going on?
that's fair. But we're going to dive into example 3. Where is example 3 centered? 1.
Oh, but, oh my gosh, it's all messed up.
It is all messed up.
So.
Just chop off the 3s and call it a day.
So I have to do the x minus 1. What am I really putting in here?
Oh, a +3. Are you gonna add in a 3? Oh.
I'm really doing plus 2, right? Because this negative 2 would distribute. So to combat a plus 2, what do I need to do?
Add a +2.
Subtract.
Subtract 2.
What?
The opposite of plus 2 is minus 2. Okay, so the center is at 1. So I'm going to put x minus 1 as my center. And that is multiplied by this negative 2 here. If I were to distribute that, I would have negative 2x plus 2. So in essence, I am adding 2 by subtracting a center of 1. So if I'm adding 2, the opposite of adding 2 is to subtract 2. So now these two things are equivalent, even though this one is much messier.
So the thing is, like, you have to put the center, but you have to make sure they're the same. So like.
Yes, they have to be equivalent.
1 minus -2 times x, or 1 minus 2 times x minus 1.
If I distribute this normally, I have minus 2x plus 2.
So
Yeah.
how is it between adding it
3 minus 2x.
minus
Yeah, but what mathematically lets you just put a number in the bottom? Because
So just like on this last one, where'd the last one go? I had to I put in a -2 for the center, right? So because I was putting in a -2 to make it equivalent and act like I was doing nothing, I had to put in a +2.
Oh,
I have to put in the opposite. Yeah. It has to balance out. Yeah.
Oh my gosh, they are.
So what does this now simplify down to?
3 over 1 minus 2 times x minus 1.
Okay. Now, this is a little bit nicer than last time because we don't have to mess with having a 1 minus. It is already a 1 minus.
But does it have to be one on top?
No, because
Oh.
A on the top is just A.
Yes. So now we can figure out.
So what is A? What is R?
A is 3, R is negative. Oh, no, R is 2 times x minus 1.
R is 2 times x minus 1. So our geometric power series is what?
The sum of 3 times 2 times x minus 1 to the n. In case you were wondering. And you would not want to distribute or to multiply the 3 by the 2. That would
No,
be-
no, 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 no,
that
no,
would be
no.
a huge no-no.
That would be a huge no-no.
Do you see that little N?
You,
That N
look,
stands for no.
the N does not stand for no-no, but you could distribute the 2. You could have 3 times 2x minus 2 to the n, but anything under the n should stay separate from your A.
Hence, N equaling no.
I put the 3 in the in. So they basically rounded it. Basically.
What's my next step here?
Oh, less than 1.
Compare it to
Negative
one.
value, is less than 2 times x minus 1.
Hmm?
Is less than positive. And we you divide by 2. And x minus 1 is between 1/2 and 1/2, and then we add 1. Creamy
Did I?
includes
Yeah.
that x is between 1/2 and 2/2. Nice. Greater.
See, this would just be boom if you had to go check.
Less than great. Yeah, you told me to shut up. But I was right.
If we just have it,
Right.
I'm
like,
This is really nice, actually. I feel like I haven't like this.
Petrel.
That's
Oh,
a man
sorry, my
on
apologies.
Zoom. He's literally filming
She's
you.
on.
Oh.
You just cannot
What
say.
the G Willikers?
Have you noticed that I've said nothing inappropriate this class?
I
yet?
appreciate that.
Missy, you're gonna be absent like 3 years from now on this lesson, and you're gonna go back and watch it, and you're like, what was going on?
Sorry, I just found like yet another place that I'm 6 years behind in math.
Where?
You know, not that we had a little, yeah, we're good.
What?
It's all good.
You didn't know where you're
Forgot.
going. Why is this that
What's-
little
what's
ball
the school
sheet up
bus?
there?
If, because she's on video.
Okay.
I forgot.
Pollock.
What did I say, Missy?
Ooh.
Anyways,
Instant
the
pass?
power series
I don't know.
representation of
I
these.
got-
We're gonna skip this example.
Yes.
Do not worry about this one.
Excel, that one right there. Why just go
We are gonna look at arctan, however.
Oh, isn't
That's
that
just
1
anyway.
minus something?
Well-
I will never ever remember what it is.
Yeah, me neither.
No matter how many times.
Guys.
You just
Equals
pulled the
1
sheet up.
minus
She's-
secant
she
squared
doesn't
x.
No, I'm looking at your test.
Oh, what test?
Oh, so maybe one test. Oh, you're just gonna see that I don't know how to do this.
I can't see that.
Guys, I'm gonna take a video.
Okay,
Oh, no, is it on the test?
no,
Oh, okay.
but let's go ahead and look at it.
just for.
But I love this.
Arctan, although no one is going to admit to remembering it,
And the negative one.
I'm pretty sure it's 1 minus.
Oh, it's one
It is
minus secant of X. Easy.
Yeah, obviously,
it is this.
What?
obviously.
Oh, and that's the answer?
No.
Your calculus these days aren't in there.
What's A?
One.
One.
What's R?
Oh,
X squared.
negative.
Oh, negative.
Negative X squared.
Yeah.
Get roasted, Bobo.
What is
Well-
your issue? Why do you have a problem? What did I
So-
do to you?
If I were going to write a power series representation of just this, just what's inside the integral, what would I do? Negative X squared to the n. Now,
Compared to one.
yes,
If it doesn't say like C, we just assume it's 0.
if it does not say C, assume C is 0. Yes,
Oh, is
good
this
idea.
gonna be between, like,
Okay, before we move on,
Now we have to take the antiderivative of that.
before we do that, that negative, how do exponents work?
In terms of what?
Would it be like 1 over?
Oh,
X
it'll
squared?
just cancel out.
You
No.
multiply it.
No.
It's multiplied by itself.
Yeah.
What does the exponent go to?
7.
The in front.
For a derivative or like-
I'm not talking, I'm just basic exponent rules. What does the exponent, I don't want to use the word distribute because that's not,
It means you.
what is raised to the n?
Oh,
X.
see.
What parts of our base?
No, only the square, I thought.
Oh, because you multiply them.
It's technically negative.
Could I
X to the
separate-
2n, Right?
-1. Yeah, you could.
Could I separate it
No, no.
and have the n go to both?
Yeah.
Yeah.
I have no idea.
Yes,
then
yeah.
isn't it an
alternator?
That does look like an alternator,
Oh,
Bobo.
Oh my god, this is why you got that scholarship.
Because I know what alternators look like. Yeah.
When I have an exponent raised to an exponent, what do I really have?
The
Exponent.
No,
No, multiply.
They're
My
multiplied.
bad.
They are multiplied. Now, Riley, I want to take the antiderivative.
Oh, good.
Okay. Here's the thing. What do we know about alternators in general?
They alternate.
Thank you.
Oh, we
Don't
don't
Yeah, they're
care
kind
about.
We just kind of ignore them. Excellent. We're going to do the same thing.
I love playing with that.
How do I take the integral of x to the 2n with respect to x?
Oh, it's 1 over 2n plus 1?
X to the 2n plus 1.
Yes. Oh,
And then I divide by my new,
denominator, which is 2n plus 1?
Yep.
Yes.
divide by that new exponent.
Because you can't add the.
Wait, okay, so what's the?
Yeah, but why is it?
Oh,
That's it.
I get it now.
Oh, it's just that?
That is it.
Oh, yeah. and what-
Wow, that's.
And that equals arctan?
That is equal to arctan of x.
So like, Christine, what does this tell you?
Well,
Wait, why?
so this is because that's how integrals work. If it was x squared, I would add 1 and then divide by 3.
Oh, you're.
Right. The derivative of x, or the integral of x squared is 1/3 x cubed. Same thing here. I add 1 to my power, divide by my new power. So Riley asks, what does this tell us? Well, now that we have this geometric power series, we could write out a Maclaurin for arctan.
What?
Why are you
Oh.
smiling?
But why?
I forgot what was
I thought it was
Maclaurins are power series centered at 0. So if n is 1, what's my first term?
One.
Negative
Actually,
x squared.
That is what, oh, we're plugging it in.
That'd
Or
be,
negative
X
x
to x
cubed over 3.
over 3. What if, oh, I missed a term. What if n was 0? Because that is actually where it starts. X,
Over 1. I know.
yep, over 1.
Okay. Wait, oh, wow.
What about 2? Uh-huh. And
Minus x to the 7th over 7.
good.
Oh, yeah.
It does kind of look like sine. What's the differences?
So if there's negative,
There's no factorials, okay, and that's because we had to take the integral and we didn't have any factorials going on there either. And taking the integral of factorials is kind of a butt and a half, so we won't mess with that. Okay, so this is what giving a power series representation will give us. Okay, so we now have a series to estimate arctan. Okay, just like with Taylor-Maclaurin's, we could estimate sine and cosine pretty well. Okay, you now can estimate arctan.
might you give us something similar to this, but with like a center?
I don't think I'd give you a center.
Is there gonna be a question like this that we will see in the future?
Let's pause.